All right, I have a question for you. Are these two lines that we see here on the screen, are they parallel lines? Now remember, parallel lines will never meet. They have the same distance apart from each other all the way along. So are these two lines parallel? Well, yeah, they look parallel, but in mathematics there's one particular thing we're looking for. We can't just look at them and say they are, because they might be just a tiny bit out. So we have to mark them as being parallel, usually with these two little arrows. Okay, that indicates that these lines definitely are parallel. So in this case, yes, they are. So what implications does that have when we do a line that runs right across it? Okay, so I've got a pair of parallel lines and I'm doing a straight line that just cuts right across it, because in mathematics this creates what we call a transversal. So this line is called a transversal. Now what on earth does that have to do with anything in terms of geometry? Well, it creates for us some really interesting combinations of angles, and the first one is this one here. Okay, now I'm going to give these types of angles, I'm going to name them by a letter. That's not their real name, we'll explain their real name, but you'll see there's a shape that's like a Z here. So this angle here, so these lines forming that pattern, it's a Z pattern. So I'm going to call them the Z angles, but their actual name is alternate angles. Okay, so the Z angles are alternate angles, and that is useful to us because if I look at the angles inside the Z, so this bit here and this bit here, in alternate angles they are the same. So if we see this pattern, this Z pattern on, remember it has to be parallel lines cut with a transversal, then these two angles inside the Z, we know that they're the same, and we'll look at some examples with some numbers shortly. But that's our first one, the Z angles. So what else can we see on here? Well, hang on, before we go on, the Z doesn't have to always be in the same place. This is a Z angle as well. So imagine this was a back to front Z that's kind of been stretched out. Okay, that is also a Z. So that means I've also got alternate angles in these two places. So I know that these two angles are the same. All right, there's our Z angles. What other letters can we see on here? Well, there's a kind of one that jumps out at me there. It's the F. And those F angles actually have a mathematical name called corresponding angles. Right? And it's the angles that sit under the bars of the F, like in here. You'll see that they kind of both sort of shoot off in this same direction. So the angles under the bars of the F are the F angles, and they also are the same. So our corresponding angles, our alternate angles are the same. Well, our corresponding angles are also the same. And just like we had before, the F could go back to front. There's some corresponding angles. The F could be upside down. There's a pair of corresponding angles. Or it could be upside down and back to front. Okay, it's just the F shape. It doesn't have to look exactly like an F, but where I see these angles, I know that they are the same. The last one we want to look at is the C angles. You can see I've made a C shape here with the parallel lines and the transversal. And we call those C angles, their mathematical name is co-interior angles. Now these ones are a tad different. You'll see the previous two, these were the same. Okay, so alternate angles are the same, corresponding angles are the same, but co-interior angles are the angles on the inside of the C shape. They're not the same. They in fact add up to 180 degrees. Okay, all the time. Inside the C, those angles will always add up to 180. And just like the others, the C can go backwards. Okay, we're just looking for the shape. So let's look at some examples with some actual numbers. Let's say this was the problem that you were presented with in a geometrical question and you needed to find out the value of x. Well, I'm looking for one of those three shapes, the Z, the F, or the C angles. And I can see I've kind of got a Z shape in there. And I know that the angles on the inside pieces of the Z are the same. So here's how you would write your answer. Looking at that, I know that this is 110 degrees. So we're going to write x equals 110 degrees. Now you can't stop there. In maths, you always need to write, excuse me, when we're doing these kinds of questions, you need to write the reason. Okay, and the reason that I know it's 110 is because they are alternate angles. And this little symbol here, this little angle symbol, is a shortcut way of writing the word angles. So I could say this value is 110 because they are alternate angles. Let's have a look at this question. Find the value of this angle, the unknown angle x here. Well, I'm looking for a shape, ZC or F. I can kind of see a back to front F there on that question. So these are going to be corresponding angles. And corresponding angles, I know, are the same. They're the angles on the undersides of the bar of the F here. They're in the same place, just one is above the other. And I know that they're the same, so x must equal 80 degrees. But once again, I have to write my reason, and my reason is because they are corresponding angles. I'm just using this property of corresponding angles being the same to work out my value. Let's have a look at a couple more. These two here. All right, if we're given 80 degrees and an unknown x, I'm looking for a Z, C, or an F pattern, and I can see that there's a back to front C there. So these are going to be co-interior angles, and I know they have to add up to 180. So here's the way I like to do this. Start with 180. All right, so my value is going to be 180 minus the 80 degrees that we're already given. So that leaves me with 100 degrees. Don't forget, you have to write your reason, and they are co-interior angles. Let's have a look at one last example, because often in geometry, you're going to get, I like to call them like little geometrical crime scenes. So you might get a question like this one. Now, none of these look like Z, C, or F angles. So I can't just sort of go straight into, is it a Z, is it an F, or is it a C? But I do have some other clues. Now, I can remember from a previous video and previous work where two straight lines cross, I get what we call an angle in here, which is vertically opposite to the 75 degrees. Okay, this angle and this angle, they're like opposite each other where the two lines cross. And I know that vertically opposite angles are the same, so this angle must be 75 degrees. So that's the first step. But how does that help me solve x? Well, now I can see my back to front F. I've got some corresponding angles. So if this is 75 because it's vertically opposite, this must also be 75. And my reason is it's a corresponding angle to this angle, which was vertically opposite to this angle. See the way they're connected? Like I had two different ideas that I applied to get down to my final answer. Guys, that's it. Your sort of quick introduction to alternate, corresponding, and co-interior angles, and how we can use them to start to solve some geometrical problems, just like little geometrical crime scenes that we can get our hands on and get stuck into and try and solve for the unknown. Good job. Well done.